All right, we're working with quadratics here. This question is from your homework. It was number 11. They've given us a diagram. They made a pizza. We're just using the actual shape of the pizza. And what we know is the radius of this pizza is x. The first question asks us for the area of the pizza. So what we're going to do is we're going to write down the formula for area of a circle. The area of a circle is equal to pi r squared. X. R in this case happens to be a distance of x. So the area of our first circle is pi. We're going to replace r with the value of x squared. So in other words, it is pi x squared is the area of this circle. Pretty straightforward. All we did was replace r with the value of x. Part B says the area when the radius is 5 centimeters greater. Okay, so let's create that circle. Oops, one. Let's go out on a limb and say that this is approximately 5 centimeters bigger, the radius of this circle. Okay, so when we go to do that, the radius of the other circle is, how would we write that as an expression? It would be x. Anyone know? Plus 5, right? All that they've done is they've taken the radius from the other circle and they've made it 5 centimeters longer. So it's x plus 5. We still don't know what the radius is in the first circle. So let's find the area of the second circle here. We have the exact same formula for a circle. Area of a circle is pi r squared. But in this case, r represents x plus 5. So we get pi times x plus 5. We replace r with our new radius squared. Okay? I could leave it like that, but we want it to be in expanded form. So we're going to work on expanding these quadratics. So if this bracket is squared, what that means is we're repeating the bracket twice. We're multiplying it by itself. Okay? So what that means is we'll be using FOIL to do this. So we go to rewrite this. We have pi times x plus 5 times x plus 5. You guys remember FOIL? First, outside, inside, and last. What that is it helps us use distributive property when we have two binomials. Binomial means we have two numbers inside a bracket multiplied by another two numbers inside a bracket. So when they say the first terms, we multiply the first terms of each bracket. What would x times x be? X squared, good. So x times x is x squared. Those are the first terms. Then we do the outside terms. The outside term is the very first and the very last term. What would x times 5 be? Positive or negative? Yeah, so positive 5x. Inside terms, that would be 5 times x, which is positive 5x. And finally, the last terms in each bracket, which is 5 times 5, is positive 25. So using FOIL, we've just used distributive property through all of them. We then have to collect all of our like terms. Inside the brackets, what are the only like terms? 5x and 5x. They're the only two that have variables of the same power. Okay? There is no other x squared and there is no other constant, something without a variable. So we add 5x and 5x. What does that become? 10x. Great. So we get pi still multiplied by x squared plus 10x plus 25. Okay? I'm still not done though. I still have to use distributive property of the pi. Now pi represents a large number that we don't want to write in, so we use this symbol. So this symbol, when using distributive property, what that means is I have to multiply each of the terms by the pi at the beginning. So what would pi times x squared be? Yeah, I would just leave it as is, pi x squared. When we write things beside each other, it's assumed that it means multiplication. So pi x squared. We don't really want to write out the number of pi because it's a very large decimal. What about when we do pi times x, or 10x? You're right, if we were multiplying, it looks something like 31.4, but again, it'd be a huge decimal. So to keep it clean, we just write 10x times pi. You could write it in any order. You could have the pi first, you could have the pi second, or you could have it third like we have here. It doesn't matter, because when you multiply, it doesn't matter the order we multiply things in. So this is more than acceptable. And what this is saying is 10 times some number times pi. And finally, what would 25 times pi be? 25 pi. That's it. Okay? So this is very literal with distributive property, that we're just taking that symbol and attaching it to each of the values inside. Okay? Now, finally, part C of this question says, how much greater is the second pizza? Okay, so we have the formula. Oops, sorry. This is the area of the second pizza, and the area of our first pizza was equal to pi x squared. They want to know how much greater the area of the second one is the first. What operation does that mean we need to use? Subtraction. We need to subtract these. If the second area is much larger, we're going to take area of the second circle and subtract area of the first circle. So what that means is I'm going to sub in this formula for area of the second and sub in this formula for area of the first. So area of the second is pi x squared plus 10x pi plus 25 pi. That's the area of our second circle. We then subtract the area of the first circle, which is pi x squared. Now, to eliminate all the brackets, everything in these brackets is simplified. None of these are like terms. I don't have another pi x squared, I don't have another pi x, and I don't have another constant with pi in those brackets, and this is just one term. But because there's a negative symbol here, I want you to think of this like -1 being distributed into the brackets. So that -1, if I was to multiply this by a negative, what would it become? It would just become negative pi x squared. So we drop all of the brackets once we bring in distributive property. We have pi x squared plus 10x pi plus 25. And I know the pi's seem a little confusing. When we multiply -1 by any term, it just switches the operation, so it then becomes negative pi x squared. Do we have any like terms?
Yeah.
We have pi x squared and negative pi x squared, right? Oh, these colors. That's okay. This is a term in itself. There's nothing else to be similar with it, and this is a term in itself. Okay? These colors are quite off. We'll fix that after. So the only like terms we have are these two. I'm going to move them beside each other so that they're easier for us to see. We have pi x squared minus pi x squared. And then we just bring down our other terms, positive 10x pi plus 25 pi. So these are our two like terms. What do they equate to when we put them together? Yeah, they cancel each other out. One's the positive of the exact same value, and one's the negative of the exact same value. So they cancel each other out. We no longer need to include them, which means our answer is 10x pi plus 25. So the second pizza was larger by 10x pi plus 25 pi, which isn't exactly a number, but it does give us an answer to how much larger it is.